Okay, so we are about to spend a lesson looking at how to graph sine and cosine, and specifically where we get the graph from in the first place. But just a couple things. If you were needing a waiver for this or any other class that's weighted, don't forget tomorrow is the day to get that turned in to Marcia Edwards, Mr. Young's secretary. Next week is the big item. What is happening on Thursday? Your exam, Thursday the 15th. So a week from today, you've got your first test. We're going to go ahead and do that right before we get out for Thanksgiving break. We are so close to our first vacation, and it's very, very much needed. But we have just a few things to take care of before that. So we'll continue our happy minutes. We have our test. I'm going to go ahead and give you a homework assignment probably on Monday, give you a couple days, turn it in on Wednesday right before the exam, and then we'll just kind of see what happens. Does anybody have any questions about what's going to be happening or any questions in general? Okay, well, let's see here. The graphs of sine and cosine functions are periodic. This means that the function values will repeat as x increases. The sine value of a function is equal to the y value. And what's one thing we've really been stressing for a while now? When you see sine, you think what? It's the y value. Sine represents the y value of your ordered pair. Okay, at that corresponding point or angle on the unit circle. Also, the cosine value represents what? The x value. Cosine is always your x value. Sine is always going to be your y value. And then the others are a ratio of those, or possibly including the radius, which typically on the unit circle is 1. Okay, so since the graph will complete one full cycle on the interval of 0 to 2 pi, the period of sine of x is 2 pi. Now what this means is if you go ahead and look at a specific region that's 2 pi units long, you're going to see the same curve repeating over and over and over again. Now each one of these periods, we're going to go ahead and break them up into what we're going to refer to as critical points. Okay, so I'm going to go ahead and kind of walk you through what sine looks like, and then I'm going to show you how we get that graph. So sine always starts with a 0. Okay, and then we go in equal distances. In fact, every pi over 2 units, we're going to have a new value. So at pi over 2, we're going to have a maximum. So we start with a 0, we have a maximum, and then we have a 0 again. And see, that was also pi over 2 units after the previous one. So what would additional pi over 2 units now be? 3 pi over 2, where we're going to have our first minimum. And then at the next increment of pi over 2, which is 2 pi, we're going to be back to 0 again. You're going to see these same values repeat over and over and over again. This is what sine's going to look like. Okay, we always start with a 0. We go to a maximum. We go back to a 0. We go to a minimum. And then we finally finish off at another 0. Okay. So the thing about sine, this is its period. It takes 2 pi units to get this full curve. So for the next 2 pi units, I would see the exact same curve. Another 2 pi, the same curve. And I could do that as many times as I wanted. And what do you think? Can I go in the other direction? Yeah. So if I go 2 pi backwards, there we go. Now, I'm doing it to go ahead and fit the screen here, but you're just going to see this curve over and over again, whether it's going forwards or backwards. Okay? So let's take a look at these ordered pairs. Let's see where they're coming from. This ordered pair right here, now even though your x-axis is in radians, it's in terms of pi, doesn't change anything. You're still going to plot points just like you would a normal xy system. So this one right here, the first 0, that's the origin. That's the point 0, 0. What do you think this first maximum is right here? No, 0, 1 would be right here. So how far right did I have to go? Pi over 2, and then I went up 1 unit. So this is pi over 2, 1. Okay. Now what about this second 0 here? What's his coordinate? How far from the origin did I go? Pi, but I didn't move vertically. I stayed on the axis. So this point right here is pi 0. See, it just takes a little bit of getting used to because it's in terms of pi, but it's still the same idea. You move left or right and then up or down. So what about this minimum right here? There you go. So 3 pi over 2, negative 1. Okay. And then we finish up with the last point in our cycle. That's what it takes to repeat. What would that one be? 2 pi, 0. So these are my critical values, and they're going to be really useful to me. They're going to make it so easy to transform sine into whatever I want, whether I'm going to shift him left or right, up or down, vertically or horizontally dilate him. Yes. Why is the max 1? Because of the unit circle. Like, why do we get the points the way we do? So let me go ahead and show you where we get this curve from, and this will also answer your question. Hello. All right, so let's go ahead and take a look at the unit circle. Now, when we plotted points, we did them in increments of pi over 2, right? We just kept looking pi over 2, another pi over 2, and so forth. Well, let's do the exact same thing on the unit circle. Okay, let's start at 0, and we're going to go through our radians. So let's say I want sine of 0 radians. Okay, so remember, it's just like our happy minutes. Okay, I know exactly where I'm going to stop. It's at 0 radians. Here's the ordered pair. What does sine want? It wants the y value. Well, what's the y value at the ordered pair? 0. So sine of 0 is 0, right? Now, think about like any other equation you've ever come across. If you take a value of x and you plug it in, well, what do you get out of it? You get a y value. See, that's how you get your xy coordinate, right? What we're plugging in here is an x value, and I'm getting a y value out of it. So this would give me the ordered pair 0, 0. Now let's move to the very next increment. Let's go to pi over 2. Sine of pi over 2. Okay. Well, we're at pi over 2, so now I'm at the ordered pair 0, 1. What's the y value here? 1. So sine of pi over 2 is 1. That's my x, that's my y, so it should give me the ordered pair pi over 2, 1. And as we continue to go all the way around the circle, we're going to get all the other points. That's where the graph comes from. It's coming directly from my unit circle. All right. Remember, what was the third ordered pair? Okay. The third ordered pair was pi 0, right? Okay, well, let's come back over here to the unit circle. If I go one more increment in pi over 2, see, we are at pi. So I want sine of pi. Well, what's the y value at this location? 0. See, I plugged in my x value to get out a y value, and it did give me the point pi 0. Okay. Now, we're just doing them in increments of pi over 2, but this works for any radian measure I want to go ahead and plug in. So the next one would be 3 pi over 2. So what's the sine of 3 pi over 2? It's negative 1. See, that's my y value, right? So what ordered pair did that give me? 3 pi over 2, negative 1, which is the very first minimum that we came up with. Okay. Now, this is answering, hopefully, Angel's question. He was like, why is the highest it can go 1? Okay. Well, think about this at the other side. Why is the lowest it can go negative 1? What's the radius of the unit circle? It's only 1. So the furthest it can go is that radius length. Okay. And then we get all the way back around to 2 pi. But 2 pi, what's the word I'm looking for? Angles that have different measures but the same stopping place? Oh, the terminal side stops in the same place. Coterminal. So aren't 2 pi and 0 coterminal? So if I go ahead and say sine of 2 pi, the y value at this location is 0. So I get 2 pi 0. Okay. And like I said, it works for any other point that I go ahead and plug in. Like, let's say, for example, I just choose a random point. Because you're like, well, that's all well and good, Mr. West, but what about all these curves that are in between these? Where are they coming from? Let me go ahead and erase that because that's good. Of course it did. Okay. So let me go back over here. There, at least the curve is back. Let's say we chose pi over 4. Pi over 4 okay, is halfway between 0 and pi over 2, right? Well, let's look at our unit circle. If I look over at the unit circle, see, here's pi over 4. See, it's halfway between. So help me out here. What's the sine of pi over 4? Yeah, remember, it's the y value at that location, right? So on my graph, from here, at pi over 4, if I were to go straight up until I hit the curve, that right there should be square root of 2 over 2. Okay. Now, why is this graph going to repeat? Why am I going to see that same curve over and over again? Yeah. Once I pass 2 pi, those y values start to what? They just start to repeat. So see, the value of x may be getting larger because you're continually spiraling around this guy, but the y values are not going to change. So think of it like this. Okay. If I go once around the unit circle, well, then that is 1 period for sine. But if I go around again, those y values repeat, well, I'm just going to get the exact same curve. And see, if I go around a third time, there you go. So I can rotate as many times as I want, and that graph is just going to keep going. Now, I can also do what? Can I go the opposite direction? Let me go ahead and use green here. What if I went in the opposite direction? Well, that just means I'm going to get the same curve just going in the other direction. So that's where this graph comes from. You're taking those ordered pairs right off the unit circle. Does that make sense for everybody? Anybody confused by that? Okay. All right, well, let's go ahead and take a look at some interesting ideas about sine function. What do you think his domain is? Yeah, because think about it. The domain is the number of times you can rotate, right? Well, how many times can I rotate? I can rotate as many times as I want. This graph can keep going forever in both directions. So it's all real. So I'll go ahead and say negative infinity to infinity. Now, what's the range? How high is he? There you go. Okay. Okay. The highest he goes, his maximum's 1. The lowest he goes is -1. Okay, because it's coming right off the unit circle. I mean, just imagine if this unit circle were something I could hold in my hand, and I just snapped it at this point right here, and I just unraveled it. That would be creating the graph that we're looking at. Okay. So, now would the -1 and 1 be included? Yes, so I would put brackets on those. -1 and 1. Okay, well, I've got 1233, so I at least got to show you this. We'll go ahead and work with sine tomorrow. Okay, and then we'll also have our quiz tomorrow. Okay. Quiz over law of sines and cosines. All right, thank you very much, guys.